All right, so I'm going to skip example 4 just because I really want to practice with the interval notation. I'm hoping that this looks somewhat familiar to you guys from geometry, but there is a chance that it does not. You know what? I'm not sure if I'm unmuted. I am muted. Oh, no, I'm not muted. Okay. That's going to be all in the video. It's great. So interval notation. This is where we use sets of numbers like the domain and range of a function can be described by using various notations. Interval notation is a concise way of writing a set of values. So we're going to consider the set of values represented by this number line graph. So while we're learning interval notation, just for this first couple examples, instead of having an x and y axis, I just want to think about the x axis because it's kind of easier to see that way. So just our definitions. Our first one, in interval. Oh, no, it's not interval. Hold on. Man. The notation we used yesterday is not interval notation. It's inequality notation. And I really didn't make these spaces big enough. Okay, in inequality notation, sets are described using algebraic expressions. So in this example up above, we have this open circle at 2. Do you remember, does open circle mean it's included or not included? Not included, so it's everything that's less than 2. So this would be written in the way we wrote it yesterday as x is less than 2. And it's not less than or equal to, it's just less than. All right, now that notation is fine, but interval notation is kind of cooler, in my opinion. In interval notation, interval notation, sets are described using endpoints with parentheses or brackets. So a parenthesis, this way or that way, indicates that an endpoint is not included in the interval. A bracket, which is like the square parentheses, indicates that an endpoint is included in the interval. So again, looking at that same example, how would we write that? I'm going to give you guys like a little key basically. These are always written sort of to look like an ordered pair like we did with like the coordinate points. So our first little rule for these is that you're going to read from left to right. Or if it was on the y-axis, you'd read from up or bottom to top. So minimum to maximum. So I'll put minimum to maximum. Okay, so as you look at the blue there, what's my minimum value? What's my minimum value right here? All right, it'd be -5 if it was a closed circle, because you're right. It looks like it's -5. What does that arrow indicate then?
It keeps going.
It keeps going. So what do we say when it keeps going? What's that minimum value? Do you guys remember when you were little and you were like trying to one-up people and you'd be like, oh, infinity, infinity plus 1. You remember that? Okay, so it's going to be -infinity. Which would mean that if we look all the way to the right, if you had a blue arrow that went all the way to the right, it would be +infinity. In this case, we don't reach +infinity, but we're going to use our infinity symbol. So hopefully you're really good at writing infinity symbols. So on this number line, my minimum value is a -infinity. So I'd put a -infinity here. And then that comma that we have in ordered pairs, instead of it being an x comma y, now I want you to think of it as a minimum to a maximum. You can think of that comma as like the word 2. What's my maximum value on this interval? It's a 2. All right, so now our next rule, and we wrote it out in those blanks, but let's kind of quantify it. If you have an open circle, so an open circle on a number line, that gets a parenthesis, this way or that way, because it's not included. versus if you have a filled in circle, that gets a bracket because it is included. Now, to note with the open circle or with the parentheses, infinities always get parentheses. I always think of that as because they're not like an actual number. They're not a real number. If you ever want like a really trippy video on YouTube, there's a video about the sizes of infinity because it turns out infinity has different sizes. It's cool. It's fun math. We won't get into it. So on this notation, that negative infinity in our example, it would get a parenthesis. And then since the 2 is an open circle, it would also get a parenthesis. So as I'm doing this, I always kind of like to write like this is my minimum value at negative infinity up to 2 with a parenthesis because it's not included. That would be kind of like the visual if you push that onto that number line. Yes?
So could there be an example where it's brackets and then parentheses?
Yes, and we're going to see that. I've given you a couple examples so we can see all the weird ways.
That's gonna be confusing.
It ges confusing, and I promise you it's a better notation than something called set builder, which we sort of did last year, and it was awful. This is, once you get it, it is like reading a new language, but once you get it, it's not too bad. So let's look at some of those examples. Uh-oh, did I post the wrong one? You guys have a different picture, don't you?
Yes.
Did I post the wrong one? That's going to upset me. Let's see. Pause. And now the internet stops working. Oh, there it is. I wonder why I didn't post that. That's weird. Sorry, let me just fix this. Ignore what's happening. You guys can look at those examples and see if you can start to answer them as I try and fix something. Okay, let's look at this one. So part A, we have interval notation here. I'm just asking us to write the domain for now. We will do this with a graph where we think about domain and range. So I always like to add my infinity. Since I have a blue arrow on the left, I'm going to put a negative infinity here. And then just because I'm a little bit of a perfectionist, I'm going to put an infinity over here too, even though we don't have a blue arrow. But those would be our minimums and our maximums. So if I think about my interval notation, what is my minimum value on that blue line? Negative infinity. And it's going to get a parenthesis. Up to, what's my maximum value there?
I think that's a 3, but I can't tell with it.
Yeah, so your guys' isn't as good. 1, 2, 3. And is that 3 included?
Brackets.
It's a bracket because it's included. And I don't know about you, but for whatever reason, I think that's easier to understand than x is less than or equal to 3. I just like this better. All right, let's look at part B. All right, again, just because I want to add these, I'm going to add my minimum of negative infinity to infinity. But what is my blue minimum there? 0. Is it included? So I would put a parenthesis. And then what do I go up to? What's my maximum? Infinity. And what does this get? A bracket or a parenthesis? Parenthesis. All right, so let me take a pause here. How do you guys feel about these first two? Okay, again, I think it's better than inequalities. All right, now part C and D are definitely better than inequalities because if you remember compound inequalities from Algebra 1, these would be those. This is better. Part C, notice I have no blue arrows at all. It's just going to go negative infinity, infinity, but we never actually reach those. What is my minimum of my blue there? And it's hard to see in yours. -2. Is it included? Parenthesis, yes. It's not included. Up to, what's my maximum value? 4. Is it included? So it gets a bracket. How about that one? Any questions on that one? Okay. Okay, part D. A lot going on here. So again, I'm going to throw in my infinities. Okay, what is my minimum x value? Negative infinity. Up to, what's my maximum x value on that little chunk, like as I read this? -1. So there's -1 right here. Does that get a parenthesis or a bracket?
Or bracket, sorry.
Bracket, because it's included. All right, now I'm just going to have a little space. Now I'm looking at this second part right here. What's my minimum value there? A 2. Is it included?
No.
So it gets a parenthesis. What's my maximum value? Infinity. Does anyone know or remember what goes between these two things?
Comma.
Not an X, not a comma. I like where your thoughts are at. It's called a union. It's a U shape. So you just do this. That's a union. So on Go Formative, there is a special button for a union. And if you find that on their keyboard, that's a correct answer. But you can also just put a capital U. That's all we put in the space. So a space always gets that union. It's just to mix or to like combine those two lines. It's like the two blue lines got married. Again, this is better than an inequality because your inequality would have been x is less than or equal to -1 union x is greater than 2. And no, that's just not as good. What do we think about interval notation? Yes.
I was gonna say, is it number 1, did we not cover that on the Go Formative?
It-
I did part of the Go Formative earlier.
It might. I'd have to look. And I do have, for like the first part of the formative, you can still use inequalities and it still should mark it right.
I couldn't-
Okay, so example 5, this is doing it in the easy way on a number line. Now let's think about this with graphs. So I'm going to color code because that was just doing the domain. Now we need to do the domain and range. So part A, I'm going to color code again. I'm going to do my domain in blue. So if I took that parabola and I squished it onto the x-axis, remember we talked about yesterday, you're going to see a lot of domains is going to be all real numbers. If I extended these lines out all the way, they would eventually hit everything on this line. So for my domain here, yesterday we would have said it was all real numbers. Today, let's think about a minimum to a maximum. What's my minimum value? Negative infinity up to, what's my maximum? Infinity. So this is the interval notation of all real numbers. So if you really forgot interval notation, then I ask you for the domain, but you know it's all real numbers and you write all real numbers, I'll give you some points. Maybe not all of them, but some. All right, now let's do our range. So we have to squish this onto the y-axis. So I see here to there. And just to be clear, this here would be a closed circle because that bottom of that actually hits it, right? So we go up to infinity here, but we don't go to negative infinity in this case. What's my minimum value for my range? Yeah, it's -6, and it is included because it's a closed circle. When in doubt, when you're squishing these functions on, just assume they're included. Basically, if you have like a number part, it probably has a bracket. What's my maximum? Infinity. What do we think of that example? Good? All right, let's see if we can do the same thing for part B. So I'm going to start with my domain. I'm going to squish this on. If I extend this all the way down, it would eventually hit everything. And that is going to be the case for most of the domains we see. So what would my domain be? Negative infinity to infinity. So yesterday we would have said all real numbers, and it is still all real numbers, but we can use this interval notation. All right, now I'm going to squish that onto my y-axis. So it would start up here, and it would be like a closed circle all the way down. So now this is why I was saying instead of left to right, think minimum to maximum. What's my minimum range here? Yeah, negative infinity. Oops, wrong color. Negative infinity up to, what's my maximum? 1, 2, 3. I gotta play with the copier so your copies aren't so terrible next time. Just a little hint. I had students really struggle with this last year, especially with the range. Sometimes they wanted to say like 2 to negative infinity. Negative infinity is always a minimum. It should always be in the left spot. Positive infinity is always a maximum. It should always be in the right spot if you have to put those two. Last one I'll do real quick just because I really want you guys to know this because this should be a freebie for your quiz. All linear functions. Do you remember what the domain and range were for all linear functions yesterday? All real numbers for both, right? So anytime a linear function is those straight lines that you guys worked with all the time in Algebra 1, your domain and range should always be negative infinity to infinity, negative infinity to infinity. So yeah, you can figure that out by squishing it onto the x and y axis, but you could also just memorize like linear functions. That is a property of linear functions. It's one of the reasons why they're kind of boring. All right, so notice these graphs are all continuous graphs, meaning we did not have to lift up our pencil as we traced over the line. Example 7 is the more interesting graphs where they're discontinuous. I won't do any more discrete, but we have some discontinuous graphs. So again, I'm going to color code here. Domain, I'm going to push these lines onto the y or the x-axis, and I'm going to use just the pen here so we can see. So this would be an open circle, and then it would go all the way here. And then if I push this down, we'd have a closed circle, then all the way there. So this looks like example 5, that last one we did. There's a space there, so there's going to be a union there in our domain. So if I look at the the leftmost point, or part of the blue line, what's my minimum value here? Negative infinity. And then what's that open circle at? If you can see it. Hard to see. Negative 1. And it's not included, so I'm going to put a parenthesis. There's a space there. I'll put the U to kind of show there's a space. What's that closed circle at? 0. And it's a closed circle, so I'm going to put a bracket. Up to, what's my maximum there? Infinity, right? For my range, start on this bottom line, goes from here, and then it would go all the way down. I do have an arrow here, so it shows that it does keep going. So it would go all the way down. And then this part picks up here, and we'll go like that. Are you guys okay with how I'm squishing that onto the y-axis still? Take some mental gymnastics. So my range, I'm going to start at the bottom. It would start at negative infinity. It would stop at negative 1 on my y-axis. And again, it's a parenthesis at negative 1 because it's an open circle there. A union for that space. And then it picks back up this time at 2 to positive infinity. You guys have questions about part A? I would turn you loose, but there's one thing I want to show you in part B that's a little interesting, so I'll do part B quicker. So part B, if I squish this onto the x-axis to start, negative infinity to infinity. So my domain, my minimum would be negative infinity to negative 1, not included. Obviously, I was lazy when I typed these in because I think that's the same function. Oh, no, not quite. A little different. There's a space. Then it picks back up at positive 1 with a closed circle. So it has a bracket up to positive infinity. Do we all see that that's true? Okay, weird things happen with the range though, because of how I graph this. If I trace that part that's in like the negative x's, so on the left over, I'd have an open circle here, but then it'd go all the way down. And then if I trace the right part, it'd have a closed circle here. It'd blow through that open circle all the way up there. So what's my range? What would my range be? Do you think it has a union? Is there any gap? No, so it does not actually have a union. And then because we went through that open circle, even though originally there was an open circle there, this part of the line does hit that value. So actually that is also part of our range. So it ends up being negative infinity to infinity. So if you ever squish your functions together and that happens, it's okay to have an all real numbers for that. That can happen. All right, do we have any more questions? You might have lots of questions, but maybe you just need to practice and see